Today we're going to be talking about how to find the moments of the system. This is a physics application of calculus, and in this particular problem, we've been given three masses. That's what we have here for m sub 1, sub 2, and sub 3. So we have a mass of 4, a mass of 2, and another mass of 4, and we've been told basically the coordinate point at which those masses are located, and we need to find the moments of the system. So your moments are going to be defined as m sub y and m sub x. That's how you'll see them written. And so the moment here, m sub y, we're also going to need to find m sub x. These are the two moments of the system. And basically the way you want to think about this, when you're finding m sub y, you're going to be multiplying the mass of each object by the distance that the object is away from the y-axis. That's the way I like to think of it, because we're finding m sub y. You want to multiply it by the distance the object is away from the y-axis. So in the case of m sub 1, our first mass, the mass is 4, and we're going to be multiplying that by 2. 2 is the distance that the object is away from the y-axis because x is equal to 2. And this can be confusing because you're taking the x-coordinate and we're talking about m sub y, but of course 2 is the distance that the mass is away from the y-axis. And one way that we can think about this, we can actually plot these points, and sometimes you're given the masses on an xy coordinate plane like this and told to find the moments, and so you'll need to do the same thing. But essentially, if we have our x and y axes like this and we plot each of the points, we can see it visually. So if we say m1 is at 2, -3, we can say 2, -3, so that mass is right there, m1, and you can see that if we go directly to the y-axis, 1, 2, that this is a distance of 2 away from the y-axis. So that's how we know that it's 2 units away from the y-axis. Same thing here with m sub 2. It's at -3, 1. So we go -3, 1. This here is m sub 2. We want to know how far away from the y-axis it is. Well, it's 3 units away from the y-axis. And in fact, it's -3 because you're essentially always starting from the y-axis and moving toward the mass. So if I start from the y-axis here, I move a positive 2 units to get to mass 1, which is why I put in a positive 2 and the x-coordinate is positive 2. If I start from the y-axis here, I'm moving -3 units. I'm moving 3 units to the left to get to mass 2, which is why the x-coordinate is -3, and that's why, to find the moment with respect to y here, I'm going to multiply this mass by the x-coordinate -3. And we could plot, if we wanted to, the third mass at 3, 5, which would be about here. And if I went to the y-axis, I'd go a positive 3 units to the right to get to mass 3. So I'm going to multiply the mass 4 times the x-coordinate 3. So plus 4 times 3, and this is just an arithmetic problem. We get 8 minus 6 plus 12, which gives us 14. We'll do the same thing for the moment with respect to x here. We'll take the masses again, but we'll multiply them by the distance that these masses are away from the x-axis. So for this first one, here's mass 1. We start at the x-axis and we go down 1, 2, 3. So -3 is the distance that it is away from the x-axis, which of course is the y-coordinate. So we're just multiplying by y-coordinates here. 4 times -3 plus the mass 2 times positive 1 plus the mass 4 times the y-coordinate positive 5, and then we solve this. -12 plus 2 plus 20 is going to give us a moment here of 10. And that's it. That's how you find the moments of a system when you're given masses at coordinate points. So I hope you found that video helpful. If you did, like this video down below and subscribe to be notified of future videos.